Ever look at the Great Pyramid of Giza and just wonder, how? It's not just a big pile of rocks. It's an ancient skyscraper, a masterpiece of engineering that still baffles us today. For thousands of years, it was the tallest man-made structure on Earth, and the precision with which it was built is simply mind-blowing. Forget aliens and lost technologies. The real story is about human ingenuity, meticulous planning, and a level of skill that is almost unbelievable. So let us peel back the layers of sand and time and explore the engineering genius that created this wonder of the world. First, let's talk about alignment. The Great Pyramid is oriented almost perfectly to the four cardinal points: north, south, east, and west. The north-south axis is off by just a tiny fraction of a degree. How did they achieve this without a compass or GPS? Ancient Egyptian astronomers were masters of the sky. They likely used a method involving tracking the stars. By observing a star's rising and setting points, they could find true east and west. Then, by bisecting that line, they could determine a perfect north-south meridian. This initial step was the foundation for everything that followed. Getting this wrong would have thrown the entire project into chaos. This wasn't just a religious choice. It was the first critical step of a massive, mathematically driven construction project. With the site aligned, the next phase was the architectural layout. The base bacteris, a near-perfect square, with each side measuring about 756 feet. The difference between the longest and shortest sides is less than 8 inches. That's an accuracy of over 99.9%. This wasn't guesswork. It was the result of sophisticated surveying and mathematical planning. We know from records like the Rhine Papyrus that the Egyptians had a deep understanding of mathematics, including geometry and a value for pi that was surprisingly accurate. The pyramid's proportions, its slope, and its internal chambers were all planned in advance. The man credited with overseeing this monumental task was the vizier and architect, Hemiunu. He was the master planner, the chief engineer who translated the pharaoh's vision into a concrete, or rather limestone blueprint. Hemiunu wasn't just building a tomb, he was managing one of the largest construction projects in human history. So, how did they maintain this incredible accuracy while stacking 2.3 million stone blocks, some weighing as much as 80 tons? It came down to their tools and techniques. They didn't have lasers, but they had effective surveying instruments. They used tools like the Merkhat, an instrument for tracking star alignments, which helped them maintain straight lines over long distances. For vertical accuracy, they relied on the simple but brilliant plumb bob, a weight suspended from a string, to ensure walls and corners were perfectly upright. They also likely used a groma-like tool, a cross-shaped device for laying out right angles on the ground. By using these tools systematically, they could check and recheck their work at every stage. Each course of stone was laid with astonishing precision, with gaps between them often less than a millimeter wide. This tight fit wasn't just for looks. It was crucial for the structural integrity of the entire pyramid. The sheer logistics are staggering. Quarrying, transporting, and lifting millions of blocks required a level of project management we'd recognize today. But it less the precision that elevates the Great Pyramid from a massive structure to a work of genius. Every block had its place, every angle was calculated, and every level was checked for accuracy. This wasn't brute force. It was a symphony of mathematics, astronomy, and hands-on engineering. The Great Pyramid stands today not just as a monument to a pharaoh, but as a timeless testament to the incredible capabilities of ancient engineers. They didn't just build for their time. They built for eternity. Ever stood in front of an ancient wonder like the pyramids or Stonehenge and just thought, how? How on earth did they move those colossal stones, some weighing up to 70 tons, without the cranes and trucks we have today? It's a question that has baffled experts for centuries. But modern research is finally shedding some light on their incredible engineering genius. Let's dive into the secrets of these ancient movers. One of the most compelling theories comes straight from an ancient Egyptian tomb painting. It depicts a large statue being pulled on a sled by a massive team of workers. But here's the clever part. In front of the sled, a person is shown pouring water onto the sand. This wasn't a ceremonial act. Scientists tested this and discovered that adding just the right amount of water to sand reduces friction by a staggering amount. It makes the sand firm and allows a heavy sled to glide over it with much less effort. This simple trick of lubrication could have cut the required workforce in half. So instead of 1,000 people, you might only need a few hundred. Speaking of workforce, coordination was everything. Imagine hundreds of people pulling on ropes, all needing to pull at the same time with the same force in the same direction. This was a symphony of human power. Foremen would have used drums, chants, or hand signals to keep everyone in sync. Each person was a small part of a giant human machine, working together to achieve the impossible. It wasn't just brute force. It was organized, disciplined, and incredibly well managed. This level of project management is impressive, even by today's standards. Now, what about the idea of rolling the stones on logs? It's a popular image, but many experts are skeptical, especially for massive blocks. Wooden rollers could easily get crushed under 70 tons of weight. Plus, on uneven or soft ground like sand, they just sink. The sled method, especially with the wet sand technique, seems much more practical and efficient for the terrain of places like Egypt. While rollers might have been used for smaller stones or on paved roads, the sled was likely the heavy lifter's best friend. But what about moving these stones over long distances? Many of the giant granite blocks used in the pyramids came from quarries hundreds of miles away. This is where another masterpiece of ancient logistics comes into play: the Nile River. The Egyptians were masters of water transport. They would wait for the annual Nile flood, which would bring the water level much closer to the quarries and the pyramid construction sites. They'd load the massive stones onto wooden barges and float them down the river. Archaeologists have even discovered ancient papyri like the diary of a man named Mirror, which detailed the logistics of transporting limestone blocks to Giza via a system of canals. It was a sophisticated seasonal operation planned with incredible precision. From the moment a stone was cut from the quarry, its entire journey was mapped out. Special ramps, some of which we can still see traces of today, were built to move the blocks from the riverbank up to the construction site. It was a complete end-to-end system, combining quarrying techniques, land transport with sleds, and a massive water transport network. It wasn't one single trick, but a combination of ingenious methods and an immense, highly organized labor force. So the next time you see these ancient megaliths, don't just see a pile of rocks. See the incredible human ingenuity, the teamwork, and the deep understanding of physics that allowed them to build monuments. Have you ever stood in front of a picture of the Great Pyramid of Giza and just wondered, how? How on earth did an ancient civilization, without modern machinery, lift millions of massive stone blocks, some weighing as much as a truck, to build something so monumental? Well, you're not alone. For centuries, this has been one of history's greatest mysteries. Today, we're diving deep into the most popular theories, all centered around one simple yet brilliant idea: ramps. Let's start with the most straightforward concept, the straight ramp theory. Imagine a single massive ramp leading from the ground directly to the top of the pyramid. Simple, right? This theory suggests that as the pyramid grew taller, the ramp was extended longer and higher. The main advantage is its simplicity. It's a direct, brute force method. However, the cons are huge. To maintain a manageable slope for workers to push the blocks, say around 8%, the ramp would have needed to be over a mile long by the time it reached the top. The amount of material needed to build this ramp would have been almost as much as the pyramid itself. Where did all that material go afterward? It's a logistical nightmare, which is why most experts have moved on from this idea. So, what's the alternative? Enter the zigzag or side ramp theory. Instead of one long ramp, this theory proposes a ramp that wraps around the pyramid like a giant staircase. As workers built up a level, they would also build up a section of the ramp on one of the pyramid's faces. This solves the length problem of the straight ramp. You wouldn't need a mile-long structure cluttering up the desert. But this theory has its own issues. The corners would be incredibly difficult to navigate with a multi-ton block. Imagine trying to make a sharp 90-degree turn with something that heavy. It would require complex pivoting systems and a lot of space, which seems inefficient. Plus, a ramp like this would cover the pyramid's faces, making it impossible for surveyors to ensure the angles and lines were perfectly straight as they built upwards, which we know they were. This brings us to a fascinating and more modern idea, the internal spiral ramp theory. Popularized by French architect Jean-Pierre Houdin, this theory is a game-changer. It suggests that an external ramp was used only for the bottom third of the pyramid. After that, the workers built a ramp asterisk inside asterisk the pyramid itself, corkscrewing its way up just behind the outer casing stones. This is brilliant for a few reasons. First, it solves the material problem. The ramp is part of the structure. Second, it leaves the pyramid faces clear for measurement. And third, it explains some strange anomalies, like a small notch discovered on one of the pyramid's corners, which Houdin suggests was a corner opening used to turn the blocks. This inside-out approach is compelling, and some non-invasive scans of the pyramid have shown density variations that could potentially be a hidden internal ramp. So, is there any physical evidence for any of these ramp theories? Absolutely. Archaeologists have found clear evidence of ramps at various quarries and unfinished pyramid sites across Egypt. For example, at a quarry in Hatnub, a well-preserved ramp system was discovered with post holes on either side. This suggests workers used a system of ropes and wooden posts, like a sled-pulling system, to haul alabaster blocks up a very steep incline. This proves the ancient Egyptians were masters of ramp technology. While we haven't found the exact ramp system at Giza, these smaller discoveries show us that ramps were definitely part of their construction toolkit. So why, with all these theories and all this evidence, is it still a debate? The main reason is that the Great Pyramid itself is remarkably clean. After construction was complete, the Egyptians did a phenomenal job of clearing away almost all evidence of their work. They dismantled any external ramps and polished the pyramid's surface, leaving us with the magnificent but mysterious structure we see today. Without a time machine or the ability to deconstruct the pyramid stone by stone, we can't be 100% certain. Each theory has its strengths and weaknesses, and the truth might even be a combination of several methods. The internal ramp might have been used for the top sections, while a zigzag ramp was used for the middle. When you picture the Great Pyramids of Giza, what comes to mind? For many of us, it's the image from Hollywood movies. Thousands of slaves toiling under the whip, forced to build these massive tombs. But what if I told you that story is almost entirely wrong? The truth, uncovered by archaeologists, is far more fascinating. The pyramids weren't built by slaves, but by a dedicated and highly organized workforce of skilled Egyptian citizens. So who were these people? Thanks to incredible discoveries at sites like the Giza workers' camp and a village called Deir al-Medina, we can paint a surprisingly detailed picture of their lives. These weren't just temporary shacks. Archaeologists found well-organized towns with bakeries, breweries, and even fish processing facilities. This tells us the workers were well-fed. Their diet was actually pretty good for the time. They ate a lot of bread, drank beer, which was a staple food, and had access to protein from fish, cattle, sheep, and goats. These were provisions fit for valued laborers, not the scraps given to slaves. Their housing was also quite structured. They lived in long gallery-like dormitories arranged in blocks. It was simple, but it was organized and provided shelter for the thousands of men who came from all over Egypt to work on this national project. They used simple but effective tools made of copper and stone. Chisels, mallets, and saws were their instruments, and their skill in using them is evident in the precision of the pyramid blocks we see today. It was sheer human ingenuity and hard work, not some lost ancient technology. The organization behind this was mind-boggling. The workforce was divided into crews with names like the Friends of Khufu or the Drunkards of Menkaure. These crews were then split into smaller teams or files. Each group had its own overseer, who reported up a chain of command all the way to the vizier and the pharaoh himself. This structure created a sense of camaraderie and competition, which likely boosted morale and productivity. It was a massive state-run construction project, managed with incredible efficiency. Perhaps the most compelling evidence against the slavery theory is the medical care they received. Skeletons found in the workers' cemetery show signs of healed bones, amputations that were clearly survived, and even brain surgery. These people were being cared for. If a worker got injured on the job, they were treated by doctors. This is the kind of investment you make in a skilled workforce, not in a disposable one. Their graves were also found near the pyramids, a place of honor. Slaves would never have been buried with such respect, so close to the sacred tombs of the pharaohs. The lives of the pyramid builders were tough, no doubt. The work was physically demanding and dangerous. But they were not slaves. They were respected craftsmen, builders, and laborers who took part in one of history's greatest architectural achievements. They were fed, housed, and cared for by the state. They were proud Egyptians building a monument for their king and their nation, an eternal stairway to the heavens. The real story isn't one of brutal oppression, but one of incredible human organization, skill, and dedication. How did the ancient Egyptians build the pyramids? It's a question that has baffled us for centuries. But the answer isn't aliens or lost magic. It's something even more incredible, human ingenuity and a mastery of simple yet effective technology. Let's peel back the layers of these stone giants and see the brilliant tools that brought them to life. Forget complex machinery. The primary tools for quarrying massive limestone and granite blocks were surprisingly basic. Workers used copper chisels and saws. Now copper is a relatively soft metal, right? So how did they cut hard granite? They used an abrasive, like quartz sand, which they poured into the cut. As they sawed back and forth, the sand did the real grinding. For shaping the blocks, they used pounders made of dolerite, a super hard igneous rock. Imagine swinging these heavy stone balls over and over to smash and shape another stone. It was grueling, back-breaking work, but incredibly effective. Okay, so they've cut the blocks. How do you move something that weighs as much as an elephant, or sometimes a whole herd of them? This is where teamwork and clever physics come in. The Egyptians were masters of ropes, wooden beams, and levers. Strong ropes, likely made from palm fibers or papyrus reeds, were used to pull massive blocks. These blocks were placed on wooden sleds. To reduce friction, they would pour water on the sand in front of the sled, making it much easier to slide across the desert. It's a simple trick, but one that made the impossible possible. Levers were also crucial for lifting and positioning the stones with remarkable precision once they reached the construction site. One of the most mind-blowing aspects of the pyramids is their perfect orientation and leveling. The Great Pyramid, for example, is almost perfectly level, with a difference of less than an inch across its entire 13-acre base. How did they achieve this without laser levels? Water. Archaeologists believe they dug a network of channels around the pyramid's base and filled them with water. Since water naturally finds its own level, they could mark a level line along the inside of the trenches. Then, they simply chiseled the foundation rock down to that line. It's a simple, elegant solution that demonstrates their deep understanding of natural principles. And the precision of the stone cutting is just astounding. The casing stones that once covered the pyramids were cut so finely that a knife blade couldn't fit between them. This wasn't just for looks. This tight fit made the structure incredibly stable. This level of precision was achieved through patient, skillful work with those simple copper tools and abrasive sands, constantly measuring and checking with tools like plumb bobs and set squares. It was a testament to the skill and dedication of the artisans. But the technology wasn't static. It evolved. You can see a clear progression of innovation from one pyramid to the next. Let's start with the step pyramid of Djoser, the very first one. It was revolutionary, essentially stacking smaller rectangular tombs called mastabas on top of each other. It was a learning process, a giant experiment in stone. Then came King Sneferu, who built not one, but 3 major pyramids. He was the great innovator. His first attempt, the Medum Pyramid, likely collapsed. His second, the Bent Pyramid, shows a mid-construction course correction. They started at a steep 54-degree angle, but realizing it was unstable, they changed it to a shallower 43 degrees, giving it that distinctive bent look. Finally, with the Red Pyramid, Sneferu's builders perfected the true, smooth-sided pyramid design at a stable 43-degree angle. All the lessons learned from earlier mistakes culminated in this success. And all this innovation paved the way for the grandest pyramid of them all, the Great Pyramid of Giza, built by Sneferu's son, Khufu. It represents the peak of their engineering prowess, taking everything learned from Djoser and Sneferu and scaling it up to a size that would remain the tallest man-made structure on Earth for nearly 4,000 years. So the next time you look at a picture of the pyramids, don't just see a pile of stones. See the copper chisels, the water-filled trenches, and the generations of trial and error. See the incredible story of human innovation, proving that with simple tools, clever ideas, and a whole lot of hard work, you can achieve something that lasts for an eternity. Thanks for watching. If you found this journey back in time fascinating, hit that like button and subscribe for more deep dives into history's greatest mysteries.